Hi everyone, welcome to PyNet Labs and welcome to the webinar as well. So my name is Jatin and I'm gonna be the instructor to deliver this webinar. So in today's webinar, as every one of you already know that we are going to talk about the remote networking and how basically the remote networking is happening over the VPNs, or you can say over the wide area network. So this is, as a network engineer, it's a very important aspect to know you how VPNs are working and what was all about the traditional networking that all the network engineers used to do on in case of connectivity if they are trying to communicate from one side to another side. So like this. So this is how like we all will be discussing in this webinar today, like how the remote networking is being defined and what is the use of VPN. And apart from that, we'll try to see what is the exact meaning of VPN, like where exactly this VPN is being used. And apart from that, we'll see the types of VPN, that what are the different types of VPN we can configure over the wide area networks, as well as we will see the topologies of VPN. And by the end, like we are going to see some basic lab setups for VPN, where we'll be implementing some DM-VPNs, and I'll also show you GRE tunnels, like how you are going to implement with the GRE tunnels. So, when it comes to the VPN, it is something which allows the user to securely connect over the network by just encrypting the connections or the devices. And there are various things which can be done with the VPNs, like you can implement security and all these things are there. But we'll be starting with the traditional networking as of now. Like what exactly the traditional router based networks were like. So when we talk about the traditional networking, or we can say the traditional router based networks. So let me write the heading as traditional router based networks. So when I say this traditional router based networks, what I specifically mean by this statement or by this heading, that we are specifically mentioning about the traditional concept of the networking, which is used previously before the announcement of the VPNs. So what exactly it was all about? For example, there is a site A. This is one customer site, and we have given the name of site A to the customer site. And there is some another site, let's say this is your site B, and also you have some site C. Now, in case if you want to get connectivity with the site A to site B and with the site C as well, let's suppose that this is your main head office and these are your spokes, we can say the branch offices. Now, to get the connectivity, what ISP was about to do, like ISP will take some connectivity, let's say some serial links or some gig links can be used. And here, like the concept used in the traditional network was all about the lease lines. So with the lease lines, the networking was happening, like communication was happening, you can say from one side to another side. So these traditional router based network connects the customer sites through the routers via some dedicated point to point links where we can configure and define the term as the lease lines. So there were advantages that, the concept of lease line was pretty much secure. So it was secure, that is one thing. And apart from that, being secured, it was utilizing high bandwidth, and it was giving you a superior quality, or we can say it was pretty much reliable, as it was some point to point links which were directly connected to the branch offices. But as in comparison, like when we are going to say that the disadvantages of using the DMVP, this VPN, just let me reshare the screen, guys, just a moment. So I hope my screen is visible to every one of you now.
Yes.
All right, perfect then. So you can let me know if any other doubt is there in between related to any screen issues or anything. So this was the point which I was mentioning, that we do have some traditional router based networks where, like, if I'm having this site A, assuming this is my main branch office, this is my branch offices like B and C, and this is the main head office. So the connectivity was established via some dedicated point-to-point links, and where via the lease lines we were able to get the connectivity with the different branch offices. So that was the thing with the traditional networks. And now, like, there were various advantages, that it was pretty much secure, it was reliable, but as in, like, we talk about the pros and cons, so like there will be some disadvantages. So the disadvantage was that it was pretty much expensive, as like most of the organizations, like let's say for small scale enterprises there, so it was not a reliable thing, or you can say a kind of better solution for small scale enterprises to implement these lease lines and all that part. So this is one thing with the traditional networking, which is something like not being really used in today's scenario. Now, apart from this traditional networking, we are like moved towards the VPN, like as the webinar name itself implies, that redefining the networking with VPNs. So how basically the remote networking is going to happen, and what is basically the VPN is going to do with you, and how we will be implementing the VPN, and what are the technologies which can be implemented with the VPN itself. So let's try to understand about the VPN. So I'll write the heading as Introduction to VPN. And when we talk about the introduction part, so as in, like, there can be lots of things which can be defined. So, the very first thing which I want to define about the VPN is that VPN is something which is a most common type of WAN connection. So we can write the first point, most common type of WAN connections which we have over the internet. Now, when I say most common type of WAN connection, what I simply mean is that the best part about VPN is that we are going to build our own WAN connections over the internet, which in simple means, like, for example, let's say there is one branch office. Let's say this is your Hyderabad location, and this is some ISP in between. And from Hyderabad, let's say there is one office which is on the Gurgaon location. So to get the connectivity from your Hyderabad office to the Gurgaon location, in between there is ISP. So what you are going to do is you are going to build a logical tunnel in here between your Hyderabad office and your Gurgaon location. So by using the VPN, you are going to build your own WAN connection over the existing internet, which is already there. So this is one thing. And apart from that, it can be internet, or it can be any other MPLS technology, or any kind of WAN connections. So when I say the introduction of VPN, so VPN is something which has replaced the dedicated point-to-point links. So let's write here, VPN has replaced the dedicated point-to-point links. So I'm going to write P2P, means point-to-point links. And while replacing these links, it has replaced these point-to-point links with some emulated point-to-point links, we can say. Some emulated point-to-point links where we can have the reachability, and that do shares the common infrastructures, that shares the common infrastructure. So that's one thing about the VPN. And like, the primary use of a VPN is like used by the customers. So the customers are using the VPNs just to reduce the operational cost on the enterprise networks. So that is one thing. And apart from that, various other technologies can be implemented with VPN. Like, when we say there are various technologies, like one of them is your ATM, which stands for asynchronous transfer mode. We have MPLS, which works in ISP core. We have GRE tunnels. We have DM-VPN. And this DM-VPN GRE tunnels, it can be configured with some IP sec as well, just for a better security. Then we have some remote VPNs. So that's one thing about the VPN. When we talk about like what's the use of the VPN and how basically we are going to define the VPNs. Now, on the other hand, there are some VPN logical topologies which we need to understand, like what kind of topologies are there on the VPN. So let's try and see that. I'll write the heading as VPN technologies, or we can say the technologies with the topologies. And these are the logical topologies in case of your VPN. The first topology for VPN we always have is the point-to-point tunnels. So I'll write the heading as point-to-point tunnels. And with these point-to-point tunnels, when we are talking, so if you'll see, like it can be site to site or it can be remote access. So let me write here, can be site to site or it can be a remote access VPN. So like what exactly this point to point is something like, for example, if you do have one branch office and second branch office and in between there is an ISP. So there will be a point to point link and there will be a logical tunnel in between your main office up to the second main office. So there will be a tunnel in between. So that is something you can define something a kind of logical tunnel, which is there in between. So this is first thing about the VPN topologies where we have some point-to-point tunnels. On the other hand, we have some hub and spoke VPNs. So when I say hub and spoke VPNs, it is something we can say if I do have one branch office and that branch office is connected to, we can say some point to multi-point links are there. So this kind of connection is there with the hub and spoke, assuming that this is your main branch office. Then with the main branch office, let's say there is some ISP in between. So the connectivity will be established like this. Let's say this main branch office is having three sites, customer site A, customer site B, and C. And this is the main head office, which is connected over the internet using some point-to-point multi links. And we can also say that in case of hub and spoke, we can define some point to multi-point links. So that you can be able to reach the from one branch to another branch. So this is one thing. And on the other hand, we have some full mesh VPNs. Like for example, if you will be mentioning the full mesh, so let's assume that this A will be connected to B and B will be to C, and like this a kind of redundant design it is, but that's not the part to discuss as in this webinar. So this is one thing. Now, on the other hand, after discussing the VPN topologies, when we move towards the actual VPN, like which is used in the enterprise networks, so we have like, two types of VPN, which we are basically going to use in the production environments. And there are various technologies which can be implemented with these kind of VPN scenarios, which accordingly we will be using in the enterprise networks. So let's say the first type of VPN, I'm going to write the heading as types of VPN. So whenever I say the types of VPN, the first type of VPN, I always say site-to-site VPN. So whenever I say the site-to-site VPN, like what exactly the use of this site-to-site VPN is and how basically the site-to-site is being defined and how we can say that it's being used. So you can say it's a kind of LAN-to-LAN communication between the branch offices. So which mean to say, suppose that, let's write the point first, like we can say it's a LAN-to-LAN communication between the different branch offices. So that's one thing. And apart from this, like, each site needs to have a public IP to have the identity of the remote site. So in case if you want to build a tunnel, public IP is mandatory, and VPN gateways can be configured on the routers or it can be configured on the firewalls as well. So most commonly we use is something GRE in such kind of scenarios, which is generic routing encapsulations. DM-VPN can be used in this scenario, and some flex VPN is there, get VPN is there, different types of VPNs are there. So this is one thing with site to site. Like in simple, we can say, for example, if this is your main head office and you got three different branch offices, so there will be point-to-point links with your three different branch offices like this in case of site-to-site VPNs. Whereas when it comes to other type of VPN, which is basically your remote access VPN, no, what exactly in that remote access VPN we have is, so it is something we can say it's having some point to multi-point links. Let's go on the second page and write, just a moment. So on the other hand, if I'll say, I do have some remote access VPNs. And with this remote access VPN, guys, it is something, It is a kind of topology where you have one branch office. Let's say this is your main head office. And with this head office is connected to your ISP. Let's assume this is your ISP or ISP core. There can be various routers in between the ISP core, doesn't matter. But you have some point to multi-point links like this. Let's say this is your site A, this is your site B, C. And in this remote access VPN, which is the second type of VPN, here it allows the remote users to communicate from different locations to securely access the corporate networks whenever and wherever they want to access. So this is one thing about the types of VPN. I got two lab simulations for every one of you to understand the VPNs more in detail. Let me just show you the labs first, then we will be performing the labs, but just a explanation I want to give on that. So let me share my lab screen. So as in you can see, guys, my lab screen is there and I got two labs here. One is a GRE tunnel and second one is my DM-VPN. So in the GRE tunnel lab, if you will see, I got VIOS 1, 2 and 3. All the basic IP configurations are done. And some WAN interfaces are having 15.0.1 IP, 0.5, 25 dot network is being used. And one loopback 1.100 and 2.100 is created on router 1 and 2. Sorry, on this 1 and 3. But if you will see one thing here, that VIOS2 is acting as my ISP. In between, the ISP router is there. And there is a IP also, which is 10.0.12.1 and 12.2. So this 10.12.1 IP is basically, we can say, used to defined on the tunnel which I'm going to create on the wide area network in between my VIOS 1 and the VIOS 3 as well. So that is one thing. And apart from this, we will be looking more in detail about the next, which is your DM-VPN. So first of all, we'll try to understand this one, like how this GRE tunnel is going to work and what is the sense of this GRE tunnel. Then we will move towards the DM-VPN lab. So let me reshare my PowerPoint screen and we can go again and let's try to understand the GRE tunnels first, like what is the use of the GRE tunnels, and accordingly we'll move towards the DM-VPN. So let's write the heading as GRE tunnels, as it is also a type of VPN which can be defined on the wide area networks and between the enterprises, or in, you can say, in between the small scale to large scale enterprises, but not recommended for large scale enterprises. So we have GRE. This GRE stands for generic routing encapsulation. So when I say the generic routing encapsulation, this generic routing encapsulation is something which allows you to have virtually point-to-point tunnels. So first thing we can write is allows you to have virtually point-to-point tunnels. So that's one thing, that where you are going to have some point-to-point tunnels, like in the previous diagram I have already explained you. And it is used when the packet needs to be sent from one network to another network over the internet. And this tunneling protocol was developed by Cisco, this GRE. So Cisco developed this GRE, and these GRE tunnels are not encrypted. So I'll write this point, the GRE tunnels are not encrypted. Not encrypted in the sense, like whatever the data is being transmitted from one side to another side over the internet, if any attacker who is sitting in between the network, for example, this is the scenario we have checked on the lab screen, router 1 was there, router 2 was there, and router 3 was there. So if I'm going to connect these three routers, and we are assuming this router 2 is your ISP router, so let's say that this is your ISP core. And apart from this router 2, let's assume there is router 5, there is router 6. There can be different routers in the ISP core, but there will be a logical tunnel from router 1 to router number 3, where we'll be having some IP, let's say 10.0.1 and .2. So this is the IP which will be providing to the tunnel, which we are going to create in between the site 1 and between the site 3. But let's say in between, there is any attacker who is trying to access the data which is being transferred from, let's say, Hyderabad location to your Gurgaon location. So in that case, if you are using GRE tunnels, whatever the data which is being transmitted from one side to another side, it will not be in the form of encryption. It's like, easy for any hacker who knows the cryptographic terms how to decrypt the data, because as in like no cryptography is also needed, because you will see the GRE tunnels are not encrypted. So the user will easily able to capture the network traffic or the packets which are being traveling over the tunnel in between. So it's not a secure and scalable solution for large scale enterprises, because for a large scale enterprise, you cannot create point to multi-point kind of tunnels. So that is one thing. And configuration wise, it is easy to configure, because what we need to do is, as per the configuration, we need to create some point to point tunnels over the internet. And to create these things, first thing you need to understand is like, as you are working on the VPN, and routing is something which is the very first prerequisite that needs to be there. Because if you will see that, let's assume we're having some IPs, some 25.1, let's say 25.2 on this interface. So whatever these IPs are there on the WAN interfaces in my labs, these are the public IPs. And to make sure the reachability from router 1 to router number 3, and between the, without the tunnel also, there should be reachability between router 1 to router 3 in case if you want to define the tunnel. So to do the tunneling configurations, we have to perform some kind of basic configurations. Like, let's move on the lab for GRE tunnel. Then accordingly, we'll see the DM-VPN, like point to multi-point, and how come we are going to define the point to multi-point scenarios. So here is my lab screen, as you can see, guys. Now on my lab screen, as it is visible to every one of you, so I got the first scenario with GRE tunnel lab, where I'm having router 1, 2, and 3. And in between, I'm going to create a logical tunnel. So let's assume this 10.1, the square box which I have created in here, with some 10.0.12.1 IP. This is the tunnel IP which we will be providing to the tunnel in between the router 1 and 2, in between the router 1 and 3, which we will be creating. Apart from that, router 2 is acting as your ISP router. All these IPs, 15.1, 15.5, 25.5, and 25.2, these are the IPs which are the public IPs as of now, I'm assuming. And these public IPs must be there to make sure that the reachability will be there. So I got some pre-configured configurations here. Like if I'll show you my VIOS 1 configurations. So let me show you. So first thing, enable show IP interface brief. So you can see that I got the IP addresses pre-configured on the lab. Gig 00 is having 15.0.1 and loopback 1 is having 1.100. Whereas if I'll try to run the command show IP route, so no routing is being defined in here, because as of now, like, it's just some basic IP configurations I have defined in all the devices. You can verify on VIOS 2 as well. For a clarification, on the VIOS 2, you can see I'm having two interfaces, gig 00 and 01. So I'm going to say show IP interface brief. Both of the interfaces are defined like as they accordingly as per the workspace. We have 15.5, and on the other end we do have 25.0.0.5. So these are the public IPs which must be defined on the devices to make sure the reachability between your sites are there. And then we'll put some tunnel here in between the VIOS 1 and the VIOS 3. Once the tunnel configuration is done, this loopback will try to ping with the other loopback, and will try to put some EIGRP routing in between the tunnel, which is not mandatory, but for a verification purpose, we can do that. So as of now, in all the devices you have verified, let's verify on the last router, which is VIOS 3 as well. Let's see show IP interface brief. And you can see 2.100 is the loopback one, and whereas 25.0.2 is assigned on the gig 00 interface. Now, this is like the basic lab setup which I have already configured. First thing I'll be doing is point-to-point GRE tunnel over the internet between the router number 1 and between the router number 3. Then I'll be defining some routing protocol on the tunnel. But before defining the tunnel configurations, make sure that the reachability should be there between the VIOS 1 and the VIOS 3, because that needs to be reachable. In case, then only you will be ensuring that the reachability between the tunnel source and destination accordingly. So for that, what I'll be doing is I'll be putting some static routes in here from router 1 to all the routers. So let's start with the router 1. So on the router 1, I'm going to say configure terminal, and then I'm going to say IP route. I got the network as, let's say, 25.network, and the wildcard mask I'm using is /24. So it's 3 times 255 and then 0. So to reach on this 25.network, my next hop is either I can define my exit interface gig 00, or I can define the next hop as 15.0.0.5. So this is one thing I have defined. And also I'm going to say IP route, one more command just for a better reference. I'm going to say to reach on the network, 15 is already directly connected. Okay, fine, no worries. Now I'll implement the IP routing on the router number 2. So on the router 2 also, I'll be defining two networks, let's say IP route. To reach on the 15.network, 15.0.0, you have this wildcard mask, and the next hop is 15.0.0.1. Okay, then I do have 25.network as it's directly connected also, but in case you can define, let's say you have 25.0.0.2. So this is one thing, and now I'll implement on the router number 3. So I'm going to say IP route, and we got 15.network with some /24 value, and the next hop to reach is 25.0.0.5. So this is one thing to reach on the 15.network. Okay, all right, let's try a ping, do ping 15.0.0.1. So you can see the success rate is 100%. Whereas if I'll try to ping from the VIOS 1 to the router number 3, I'm going to say do ping 25.0.0.2. So you can see the success rate is 100%. So I have defined the static routing, which means over the, as a kind of ISP scenario, it's basically using, I'm as of now using some static routes, so not make it more complex, but in the real-time environments, it's configured with some MPLS, or it can be configured with the BGP as well, depending upon the type of ISP core, like how many routers are there in between the ISP. So that is one thing. But now, as we have done the basic configurations, now the next thing is, after doing the routing part, we need to create the tunnel between the VIOS 1 and in between the VIOS 3. So to define the tunnels, I'm going to select my VIOS 1. And with the VIOS 1, if you will see, do show IP interface brief. So you can see as of now, like no tunnel is there, only the gig interface and the loopback interfaces are there. So I'm going to create one tunnel. So I'm going to say interface tunnel. And if you'll put question mark, so this is the total number of tunnels which you can create in one device. So as of now, I'm selecting the tunnel as, let's say, interface tunnel 10. So you'll see a log here that the interface tunnel is down as of now. So once you have enabled this command, then you need to define one IP address to the tunnel which you have created. So I'm going to say IP address to the tunnel I'm defining as, let's say, 10.0.12.1, and the /subnet mask I'm going to use, let's say, 24. And once it is done, then we need to define the tunnel source. So with the tunnel source, if you'll put question mark, there are lots of things. Either like you can define the IP address, or also like, you can define the exit interface. But I recommend to define the, like as of now, you can use this particular exit interface or the IP address. So tunnel source for the router 1, I'm saying is 15.0.0.1. So this is the tunnel source. And then you need to define the tunnel destination. So to define the tunnel destination, you need to write the destination. So in this scenario, you cannot define the exit interface. So you need to define the destination, which is 25.0.0.2. So this is the tunnel destination. So this is one thing, exit. And now if you'll verify, do show, you can see the tunnel is also up. If you'll run the command do show IP interface brief, so you can see the tunnel 10 which you created is also there. Now on the other hand, which is the VIOS 3, let's move towards VIOS 3 now. And now on the VIOS 3, if you are going to say interface tunnel 10, It's not recommended to use the same tunnel ID on both of the sides. It's logically significant. So you can say IP address to the tunnel. Here it's 0.12.2 with some /24 value. Then after defining the IP, we are going to say the tunnel source. So the tunnel source, let's say I'm going to say is 25.0.0.2. Then I'm going to say is the tunnel destination. So the tunnel destination I'm having is 15.0.0.1. So that's how you are going to implement GRE tunnels. Like if you will see exit, do show IP interface brief. So you can see the tunnel is there now. Now, once everything is done related to the tunnel configurations, so your tunneling is done in between the router number 1 and the router number 3. So see how it is basically being defined, and according to the configuration, you only need to define 4 set of configuration. First of all, selecting the interface for the tunnel. Second one is executing the IP towards the tunnel, what you have selected. Then you need to define the tunnel source. Accordingly, you need to define the tunnel destination as well. And to have a more better verification, what I can do is I can put some EIGRP configurations over the tunnel as well. Like I'm going to say router EIGRP 10. So this something, one more configuration where I'll be defining the network, let's say 192.168.2.0, and the network I'll be defining is 10.0.12.0 exit. So these same EIGRP configurations I'll be implementing on the VIOS 1 for the tunnel part, just for a verification, but it's not recommended in the real-time production environments. So I'm going to say router EIGRP 100. Network I got is 192.168.1.0. Then I do have the network, which is 10.0.12.0. Exit. So let's see. Okay, 10.12 manually up. So if you will see guys here in this particular scenario, where we have defined the EIGRP tunnel configuration. So it's like, you know, in case of GRE tunnels, the thing is that it is point to point. All the tunnel configurations you are doing manually. It's not scalable because let's assume that if you are having 100 endpoints, so you need to build 99 tunnels manually, as well as like there is no encryptions and there should be static IP on all the endpoints as well. So it's not a scalable solution for large enterprise networks when we are defining the GRE tunnels. But now these days, we are not exactly using the GRE tunnel. We are actually working on the DM-VPN, which is a pretty much scalable solution. And this DM-VPN is something which was introduced by Cisco in 2000. And when this technology was introduced to, you know, address the needs of automatically created tunnels when some dynamic IP addresses are there on the spokes, which mean to say it's a kind of pure hub spoke topology where all the branches may communicate with each other over the hub or whatever the main branch office you are having. So with the DM-VPN lab now, guys, if you will see, so this DM-VPN is a combination of various technologies. Like, you know, we don't need to define the tunnel destinations here. It's going to give you a low cost minimizing configurations, and complexity wise, it's, you know, going to increase the flexibility of the network, we can say. So when it comes to the DM-VPN configurations, it's a combination of various things. Like we have MGRE, which is multi-point GRE. So let me share my PowerPoint screen to write some points for every one of you about the DM-VPN. Then we'll see the lab for DM-VPN. So as in the GRE tunnels, we have seen that it was something we can say point to point. Being from point to point, there was one more thing, manual tunnels. So we have some manual tunnels, manually defined tunnels. Apart from this, there was something like not scalable, we can say, for large enterprise networks. And there should be like no encryptions by default. So the data is not secure over the wide area network in case if you are using the GRE tunnels. So this is one thing about the GRE. But on the other end, when it comes to the DM-VPN, when we are talking about the DM-VPN, so this DM-VPN is something which we are going to define in case like when we are having point to multi-point links, and whenever we will be like using some one branch office to multiple branch office kind of connectivity. So let's talk about this DM-VPN, which stands for dynamic point to multi-point. So we have dynamic multi-point VPN. And in short, we call it as DM-VPN. So that's one thing about the DM-VPN. And apart from this, we can say it was introduced by Cisco in 2000. And when Cisco announced this, like it was introduced to address the needs of automatically created VPN tunnels, where like today we are using some dynamic IPs over the spokes instead of defining the static IPs. Like in case of GRE tunnels, on this side, we were having some static IP. But with the DM-VPNs, it's not recommended or it's not mandatory thing that you must be having some static IP. You can either go with the dynamic IPs. So it's a kind of pure hub spoke technology where the branches may communicate with each other over the internet securely. So we can say it's a pure hub spoke network where all the users can communicate with each other. And we also don't need to define tunnel destinations in here. No need to define the tunnel destinations because it's going to use some MGRE interfaces, multi-point generic routing encapsulation. So this is one thing I'll separately explain you, and it's going to give you like, not more complexity, and like it's going to increase the flexibility. And it's when it comes to this DM-VPN specifically. So I'll add this point. DM-VPN is a combination of various technologies. Then what are the technologies which are used by the DM-VPN? So in case of DM-VPN, the very first technology you are going to find is multi-point GRE, which stands for MGRE, and we consider it as multi-point generic routing encapsulation. Now, what exactly this multi-point GRE is? So here in case of multi-point GRE, we know we don't need to define the tunnel destination, as we are going to use some tunnel modes and tunnel source in here instead of defining the tunnel destination. So in the previous lab, instead of defining the tunnel destination, I'm going to use the tunnel mode here, which I'll let you know. And we'll use the tunnel source as well. And these tunnels can have many endpoints using single tunnel interface. So I can write here, these tunnels can have many endpoints. Many endpoints. And apart from having endpoints, you can like, use one single tunnel interface, which can be configured as MGRE or GRE in case. And here, very most important thing which it is going to use is one more protocol is being used, and that is also a specific topic, which is NHRP. This NHRP stands for Next Hop Resolution Protocol. Now this next hop resolution protocol, when we are talking about, so this next hop resolution protocol is pretty much similar to, we can say like, in this next hop, it's similar to the ARP, like it provides the mapping of private IP to the public IP and public to the private. All it do is like building the dynamic database of the branch office into the hubs and the IP addresses of the spokes as well. So this is one thing we have in here. So with this DM-VPN and HRP protocol, it's going to use two more, we can say the routers can be configured as NHS and NHC. NHS means next hop servers and NHC means clients, next hop clients and servers. So when we define this NHRP, so this NHRP is something when the client register themselves by NHRP server. Let's say if you are registering this kind of topology I'm having on the lab, where I have this router number 1 as my main branch office. Then there is some ISP core in between. I don't know how many routers are there, assuming router 1 is there. And with this router 1, let's say there are 3 or 2 main branch offices which I'm having. This is my branch A, this is my branch B. So what I'll do is I'll define this router as NHS, next hop server, and these are my next hop clients, because just to resolve the private IP to the public IP over the tunnel which is there in between. So what I'll be doing is I'll be using some NHRP protocol, which is basically recommended to use. And this NHRP server keeps the track of all the public IPs and whatever the cache memory is there with the public IPs, because it's going to send some query messages to the like these clients will send some query messages to the server in case if they are going to form the communication. So as of now, what we have seen is in the previous lab, the tunnel which we created, it was something like this. Like if you will see, let me use my highlighter. So a tunnel was created like this. It was a point-to-point tunnel which we have used in the previous lab, which was of GRE tunnel. And when it comes to the next one, which is point to multi-point, or we can say the remote access VPN. So in case of remote access VPNs, what we can define is like a kind of tunnel where we are having a connectivity from the main branch office. And with this main branch office, I'm having point to multi-point kind of connectivity like this. So this is how like we will be defining the DM-VPN, and this DM-VPN is pretty much used in the remote access VPN kind of scenarios where we'll be implementing this one. So just to make sure it's going to work fine, what we need to do is we need to define some configurations on the devices. So let's get started with the configurations for DM-VPN. So let me share my lab screen and let me show you the DM-VPN configurations and how exactly the VPN, we can say this point to multi-point VPN can be defined. So here is my lab screen, as you can see. So I hope my lab screen is visible and we can start with the DM-VPN configurations. And as of now, I don't need this GRE tunnel configuration. So what I'll do is I'll just stop these devices because we have already done the lab for GRE tunnel. But now to perform the lab of this DM-VPN, as of now, you can see all the routers are there. This router 4 is there, which is basically I'm going to assume our main branch office, like this is the main head office. And these are the two sites which are connected to this main branch office, and between there is a ISP who is providing some connectivity. And you can see it's a point to multi-point kind of tunnels where I'm having just one single link towards the ISP, and then ISP is providing the multi-point connectivity towards the main, or we can say the branch offices which your office is having. So to perform these configurations, first of all, the first thing you need to do is implement all the basic IP configurations accordingly, and these private and these public IPs must be reachable, this 15 dot network, 25 dot network, and this 30 dot network, to make sure that you are reachable to your branch offices. So for that, what I have done is I have done some basic configurations. Let me show you on the router 4, enable, and I'm going to run the command show IP route. And in the show IP route, you can see I have performed some static route default routing, which means like if I'll try to ping my branch offices, let's try to ping 25.0.0.2. So let's see, are we getting the replies? Yes, we are able to ping 25.0.2. Now you can see 100% success rate. Whereas on the other end, if I'll try to ping 30.0.0.2, the next branch office. So am I able to ping or not? So I'm able to ping because I have defined some default routing in here. So you can see do show IP route static. Okay, do will not work on the privilege mode. So you can see the static routing I have defined in here on the VIOS 4. Now, after defining the default routing, which I have basically implemented in here, to define the VPN configurations, what will be the tunnel? Like the tunnel will be from router 1 to 5, and this ISP is providing multi-point links from router 5 to 7 and 7 to 6, because these two routers 7 and 6, these are acting as our branch offices, whereas this router 4 is acting as your main office. So let's implement the configurations for DM-VPN. I'm going to create one tunnel on the router number 4 first. See guys, the configurations will be different. As in case like you are defining the DM-VPN, it's a point to multi-point. So on the server, like you can say there are two things I told you, NHS or NHC, next hop server or next hop clients, which is basically NHRP responsible for mapping the private to public IPs. But as in like if you will see here, configure terminal, first configuration is to implement the tunnel. So I'm going to say interface tunnel, and the tunnel I'm going to use as 0. So let's write the tunnel IP. So I'm having the IP of tunnel here is 10.0.0.1, having some /24 value. So this is the tunnel IP, which I have defined on my main branch office, which is 10.0.0.1. Then I'm going to say the tunnel source. So tunnel source, either I can define the exit interface or I can define the IP which is there on my exit interface, which is 15.0.1. So I'm going to say 15.0.1. This is one thing. Then after this, I'm going to say tunnel mode. And I'm going to say mode GRE multi-point, because it's a kind of point to multi-point connectivity. So you don't need to say kind of, tunnel destination. So instead of saying the destination in remote access VPNs, we are going to say the GRE multi-point. Then you need to execute one more command, IP NHRP network ID. This is basically for the resolution of private to public IP. So once this is done, simply exit the command. So these configurations are done in here. Now on the next branch office, what you need to perform, you need to execute some configurations as per the VPN. So I'll share these configurations with every one of you specifically after wrapping up the webinar. Let me write the configs for VIOS 7. Now in the VIOS 7, enable show IP route. If you will run the command, you can see default routing is also defined here using some exit interface. And the reason why I have defined exit interface in here, let's say if the company is using dynamic IPs. So as of now, if I will be using the next hop as 25.0.0.5, and on the ISP side, instead of defining the static IPs, the ISP is going to use some dynamic IPs. So it can be challenging, and it can be a kind of misconfiguration or kind of notifications you can get in here, like your IP is not accurate, whatever the routes you are defining. So it's not going to make the communication. So it's better to use the exit interface and such kind of scenarios where you have point to multi-point connectivities. Now let's run the configurations for R7. I'm going to use the tunnel 0. Now after defining the tunnel, I'll tell the IP address to the tunnel, and I'm going to say IP address 10.0.0.2/24. So this is the IP which I have defined to the tunnel. Tunnel source I'm going to define. So let's say the tunnel source I'm going to use is gig0/0, the exit interface, this one, just because of the dynamic IPs, because dynamic IPs can change anytime. Then you are going to say tunnel mode, because we don't define destination here, tunnel mode GRE multi-point. Then after defining the multi-point, you are going to say IP NHRP network ID. And this network ID command, it is also like, locally significant. So you can use any network ID in between, or if you will be using the same network ID, which you are going to use on the main branch office, that too is fine. But I'm going to use different one because it's locally significant. Then you need to say IP NHRP, because next hop resolution protocol is going to have two more things like NHS and NHC. If you will put question mark, you can see NHS is there, specify the next hop server. So this next hop server you have to define. So in the next hop server, like which is your next hop server, the main branch of it is asking about. So where you have defined the IP as 10.0.0.1. Your next hop server, like the main branch office, is having the IP of 10.0.0.1. This is one thing. Then you are going to map it with that particular IP. So you are going to say IP NHRP map. And after saying the map command, you are going to say put question mark C. It's going to ask you for the IP address or use some NBMA mapping for broadcast multicast. It's simply going to ask you for the IP address which you have defined for the tunnel. And then if you'll put question mark, again, it's asking for NBMA. So here you need to define the public IP, which is there on the WAN interface of your main branch office, which is 15.0.0.1. So this is one thing on the R7 configuration. Now, let's do the same on the router number 6 as well. So this is my R6. Now on the router number 6 also, we'll implement the configurations. So I'm going to say, let's verify do show IP route static. So you can say static routing is already there. So I'm going to select the tunnel first, interface tunnel 0. Selecting the tunnel, I'm going to write some IP addressing. So I'm going to write IP address, and after the IP address, let's say I'm going to define some 10.0.3 because I have used 1 and 2. So after defining the tunnel, we'll define the tunnel source. The tunnel source I'm going to use with exit interface, tunnel mode, GRE multipoint. Then after defining the tunnel mode GRE multipoint, I'm going to define IP NHRP configurations, the network ID 3. In case if you will not define the network ID command, then it's not going to resolve you with the private to public IP. This is one thing. Then after defining this network ID command, you need to map it with the NHS, which is the main branch office. So you're going to say IP NHRP, NHS. And what's the IP over there, which is 10.0.0.1. So this is one thing. Then you are going to say the mapping command with the configurations, like which recently we have used in the last router. So we'll be saying IP NHRP map 10.0.0.1 with the public IP of 15.0.0.1. So all the tunnel configurations are done in here. Now, once it is done, the second thing we have is, as per these configurations, now tunneling is also done. If you will go and verify on the router number 4, do show DM-VPN. So you can see in the command do show DM-VPN, I'm getting the attribute as dynamic and some peers are there, 25.0.2 and 30.0.0.2, which means if I'll go on the VIOS 6, or I can do one thing. Let's try and do some EIGRP routing. And also let me show you one more thing. Like after applying the tunnel configurations for verifications, we can do is on the VIOS 4, I'll implement some router EIGRP. So I'm going to say router EIGRP 100. Then I'm going to define the network and I'm going to say 192.168.2.0. Then I'm going to define the network 10.0.0, the network which I have used on my tunnel. So same implementations I'll be doing on the router number 7 and 6, like the main other branch offices which are connected to the head office. So let's implement on 6. Exit. I'm going to say router EIGRP 100. Network I'm having is 192.168.2.0. 3.0 is there on the VIOS 6. And then I do have the network 10.0.0. So that's one thing. Whereas on the VIOS 7, I'm going to execute the IP of 2.0 and 10. Network. So I'm going to say router EIGRP 100, network 10.0.0, network 192.168.2.0. So all the configurations for EIGRP I have done in between the tunnel. But if you will see one thing, guys, like whenever we implement the EIGRP, so will not run the command no auto summarization while communicating between the routers. As of now, like that is by default enabled. So Anurag, we don't need to, execute the summarization command because by default it's enabled in here. But if you will see one thing, like as the query was raised, so you will find that I have configured the AIGRP on the branch offices, which is my router number 7. On the router 6 also you can verify. These are the AIGRP configurations, whereas on the router number 4, the main head office executed some configurations which are related to the this AIGRP for the tunneling. But I'm not getting any AIGRP logs in here. Like if I'll try to verify, do show IP AIGRP neighbors. So you can see I'm not getting any neighbor in here. And why I'm not getting any neighbors as of now? Because I have not defined the NHRP mapping for, like, the multicast communication, whatever the communication is happening over the multicast, because the IGRP is going to use the multicast address for the communication. So that needs to be defined. Otherwise, it's not going to communicate. So to define that, we just need to execute one more command on the tunnel, selecting the interface tunnel 0, and you are going to say IP NHRP map. And after saying map, you are going to say multicast, and you're going to say dynamic here, because there can be different endpoints towards your main branch office. And over here in the clients, you are going to say just one single command to map it with the multicast, whatever the IP is there. Exit, you are selecting the interface tunnel 0. Then selecting the tunnel, you are going to say IP NHRP map, and you are going to say multicast. And after saying the multicast, you are going to define the public IP address where you want to map it with. So I'm going to say 15.0.1. So once this command is executed, same will be executed on VIOS 7, going on the tunnel, exit interface tunnel 0. And then after I'll paste the same command, IP NHRP multicast 15.0.0.1. So this is how, like, let's try to wait for some time and then we'll see. So you can see on the router number 4, now I got the dual agency logs. These logs are here that the tunnel neighborship is up with the neighbor 10.0.0.3, and we got the neighbor 10.0.0.2. So the tunnel agency is up, and you can see that the now in the AIGRP verifications to show IP IGRP neighbors, you can see the tunnel 0, which you have created on the different branch offices, which is 10.0.2. That is the IP for this branch office, which is VIOS 7, and this 10.0.3 is the IP for the VIOS 6, which is one of your different branch office. And that's how you can verify. And also you can run the command do show DM-VPN, and here you can see the peers which are there as per the DM-VPN implementation. So that's how the point to multi-point is going to work in case of your VPN scenarios. And there are various things which are pretty much related to the DM-VPNs. Like we have the phases, like we have phase 1, phase 2, phase 3. So this is the configurations for phase 2 we have done here. Phase 3 is basically being used where we can define some NHS configurations, where we can use some redirect command for multiple endpoints. So all these things are covered in the NRC part, and like this is what we have in here up to the webinar. So up to here, if anyone is having any sort of doubts and queries on any of the configurations, so you can let me know on the chat box. And apart from that, I'll do one thing. I'll share the DM-VPN configurations with every one of you in our public group, which is like DevNet, and you can join the public group of PyNet Labs. I'll share the link in the chat box. And over there, you can see the configuration files for the lab which we have done, and I'll share the files over there. So that is what we are going to see up to here in the VPN sections for this webinar. So any doubts, any sort of queries, if anyone is having, so you can let me know. So I can see like as of now, no queries are there on the chat box. So that is what we are having in here for this DM-VPN and the GRE tunnels, and how the VPNs are being implemented over the wide area network, and how basically you will be defining the VPNs. In short, like this is what we have covered in the webinar, which is redefining the networking with remote VPNs. And meanwhile, before wrapping up the session, guys, I'm just sharing few links on the chat box in case if you have not joined the Telegram group of PyNet Labs. So here on the Telegram group, you'll get all the resources which we have used in the labs related to configurations, or any sort of doubts if you do have, apart from the labs or any points we have discussed in the webinar. So you can reach on the Telegram group. So the channel link I'm sharing on the chat box, you can join the Telegram group to have the lab configurations, which I'll be pasting in the group as well after some time. Yes, Anurag, you can practice it on GNS3, but I'm not sure about packet tracer, because over the packet tracer, I guess you will be able to do the GRE tunnels, but not all the NHS commands are supported for DM-VPN on the packet tracer. So it's not a good idea to go with packet tracer. So I recommend you can use EvenG, or you can use GNS for a better simulation and all the commands which are there in the real-time iOS files, which we basically use in GNS or EvenG. Great. All right. So I hope everything is clear to almost every one of you. So that was the webinar all about in the VPN, and I hope every one of you enjoyed the section. So that is what, guys, we have in here up to the topic we have discussed, and that's the end for the webinar. So we can wrap up the webinar. Meanwhile, I guess almost every one of you have joined the Telegram group. So any doubts, queries, if you guys do have, after watching the recording, you can let me know on Telegram. We'll be able to let you know any doubts and queries if there are on Telegram group. So that is what, guys, we do have in the VPN section. And I hope every one of you enjoyed. Thank you for joining, guys.